So today this is our first section. It's 8:10, class is starting. Our first section of doing this remotely. Hopefully you all watched the 11.1 videos last night or this morning, preferably yesterday. Tried a couple problems. If not, we're just starting off. And you've got time to get in the groove of things. I know you're used to summer. Lord knows I am. And here is a warm-up problem. Try to figure out what shape this is, and if you're feeling inspired, try to graph it. Most of the problems that have been selected as exercises to practice, they are the odd numbers, so the answers are in the back. It'll only show you the solution, but that's another way of checking to see if you got the right answer. If you didn't, you can always come chat with us on Discord, share what you did, and one of us will take a look at it and be able to maybe help you figure out where you went wrong, which is a great resource to have. It's like having a Mesa Center anywhere you go. Well, not quite, but close. Got a couple people that have hopped in. Well, one. Smurf has hopped in. Is the current format of this equation really all that helpful?
What I mean? Another 2 points.
It might be more helpful if we group the y's together. What can I do with the y's grouped together? Oh, this is some algebra shit you probably haven't done in a while.
One of them said complete the square.
Complete the square, yes, exactly. So one easy way of doing it, take the coefficient here, -1, divide by 2, and square it. And add that to both sides. So 1/2 squared is 1/4. And so now we have x squared plus y minus 1/2 squared. Really? Dead green pen already? I got more. Y minus 1/2 squared plus z squared equals 1/4. What is this giving me?
I got a sphere.
It's a sphere, right? So we have a sphere. It helps to know, what do we need to know for a sphere? What's use? Center and radius. So the center is what?
Zero, I
Zero,
got someone
one
saying
half,
zero, one
zero,
half,
yeah.
one.
Radius,
The radius is a quarter.
I'm here in a quarter.
close.
Just
This is r squared on the right. So it's effectively, since we already had 0 on the right side, this is effectively r squared over here. So the radius will be 1/2. And if we want to try to plot it, we do z vertically, y is horizontal, and x is towards us. And we've got 1/2 along y, but no change in the x. Let's say that's 1/2. This is 1. So that's my center. It's got a radius of 1/2, which means it's going to have points here and here. It'll go up to z is 1/2. It'll come out to x is 1/2. And we got something in the back and down below. And this is an art getting used to drawing. I probably went too far back on the X. I think it's easier to do the YZ plane first because that's the one that's in the page. Make the circle there. And then kind of draw that it's like that. It's not my best sphere, but it will work. Maybe putting this as a solid line because it's coming out of the page. And as long as I've got that labeled as 1 there, we can tell that it's 1/2 of the radius is 1/2. Any questions?
Yes.
For like testing purposes or just for like showing work or something like that, does it matter where we draw the hemisphere? So if we I know since the draw.
Oh, you mean like how to draw the axes?
Well, no, like if I did the hemisphere like vertically instead of like horizontally, like would that matter? As long as I'm showing that it's a sphere, does it matter like where I draw it?
If I
He's
can
wondering-
identify that you're making a sphere, I'm good.
Okay.
If it's clear, it's a sphere, yeah. Like if you wanted to do this, that works too. In fact, shit, that might actually look better.
If you can make it so that it's legible, then it's okay.
All right.
Because I know for a fact that I've lost points on a test because the teacher just couldn't read it. My drawing wasn't good enough.
There will be one graph on the test. The first test will have one graph. Graphing by hand in 3D isn't the easiest thing to do. So the graph on the exam will be more straightforward one. I'm not going to get, like, if you started looking at 11.2, I show you a picture of a monkey saddle where like drawing that by hand is just not realistic. So it'll something like a sphere or a cylinder or something like that, doing 3D. It'll be something like that I'm asking. All right, let's take a look at another example. Let's see what we got. Huh. This is a fun one. This is trivial in 2 dimensions. In 3 dimensions, is it trivial?
Well, maybe for me.
So one thing I'm probably going to do, I just grabbed this from the book, so I have no idea what it's going to look like. I'm going to write it in like slope intercept form. So we got 3y equals negative 2x plus 6. Y equals negative 2/3 x plus 2. And this is y, this is x, this is z. So in 2D, negative 2/3 x plus 2 would go through the y equals 2x0 or 0, 2. And it's going to go down 2 over 3. So it's going to hit 3, 0 there. That's in 2D. That still applies. Oop. Is that it?
I'm seeing some shakes of the head.
Affirmatives or negatives?
Draw
Positive
the
head shakes or go ahead.
So draw the plane.
We need a plane, right? Because we have a z component, but z is not listed. So z is any real number, which means this can go up or down, kind of like doing something like that will indicate a plane. And if you have this line in it, it kind of helps indicate what that plane is. And graphing something beyond that is not that easy in 2 dimensions or 3 dimensions on a 2-dimensional piece of paper. But making a rectangle indicates a plane that goes on to infinity. Huh. How would we graph? I don't even know how I would graph this next one. I know what it looks like in 2D. This is my y, this is my x. So can we translate that to 3 dimensions? And the reason why I'm doing this all fresh with graphs, I don't know what they look like, is to show you how crappy you can expect your graphs to look when you're learning how to do this. I know y caps at 1 and -1, right? So 1, -1, this would be pi and 2 pi. So maybe I'll scale the x-axis. Maybe I'll only show up to pi right here. And we'll do -pi that way. That will catch the full range of the scale. So about the halfway point, it should be something like that. And about the halfway point, something like that. Maybe I'll change that to red because that's my sinusoidal curve. This is kind of, you can't like really draw a rectangle because it doesn't really do it, right? I might try something like doing little arrows showing that this extends up and down. We might draw another shape up above it that matches the curve. Shit, let's see. Go up that far. Put a point there, point there, point there, point there, point there. Maybe show it connects like that. So we're making like a plane that looks like a ribbon. That looks terrible. And yet I can do it pretty easy with a piece of paper. I can, you know, make a paper bend and look like it just fine. Right? That's the wrong way. That would be like it. So it's not, these are not easy to graph. And that's why, let's face it, if you're relying on, you need a three-dimensional picture for something and you're doing engineering or something like that, that's why you have an architect making blueprints so that you can see it better. They're really good at drawing this shit. That's their job. They draw well. If you have any questions, I'm up for answering them. Otherwise, here's a good chance to work on homework or ask questions from homework or anything like that.
I'll be walking around, so if you ever need anything, just call me.
Okay.
All the way at the end and then come back.
I didn't do any photos. So this is for the lease. To these also these line and that's what I usually do.
Yeah.
And then on the side.
Just doing that many problems. It's kind of look like this. That's a circle.
Yeah.
Just add a wide frequency.
So
you apply the same rules.
I mean, you find that in a lot of ways that there's part of like they'll change it, they'll add it to these formulas, like distance from one of those. I'll kind of just have like you'll find a little
I'm thinking about.
it's really just kind of
I can't look at this for the whole time and that. Yeah, sometimes.
yeah, but specific.
I know, I was wondering, guys, literally.
I would wait until we get further into it, so you can further understand what because it gives you a better idea of what actually can be 2D to 3D. Yeah.
How you doing, Brian? I think so. Honestly, when I was like watching the video at home,
Oh, okay.
what's going on? Because you need to just trick your eyes into seeing it.
Yeah,
It's so true. It's just sometimes it's just like it's not an issue of understanding the math. It's an issue of like it's an optical illusion that you also need to understand mathematically. So it's like,
It's weird, it's like when you can't see it, you can't, but then once you can finally see it, it's there.
exactly.
Imagine you have to preface that you breaking out alcohol is better for society.
Yeah, that's.
The fact that you don't have it will just go on forever. There's no setting. You can set a.
I don't know why.
But you have to
Look at this. That's number one.
That's why if you support
What?
people that just.
I just have the book and I just.
Yeah.
Okay, wait. I need to figure that out.
That's an interesting analogy.
Are you using good notes or what are you using?
No, I'm
We
using
live in a
something
society.
on
No.
this like Samsung type, which
Yeah, it's just like you copy anything else. You just like copy it and place it into my homework. That way I don't have to draw it.
see that's just like a PDF. Right?
Yeah, it's just a PDF of the book.
Okay. Yeah, we're gonna get
Yes. So, yeah, so it's gonna extend against the y-axis. It might not be.
You already did the wall.
Oh, yeah, I might have said it.
wait, on the first one, or you just do
Yeah.
and just like count this one out. Okay. I was like,
Because the coefficient before the square. Yeah, square variable. Oh, and find it in the other form. Give me 5. Let me see if I can remember to do this.
Say absolute value.
Well, no, you can't finish the whole problem. I learned that the hard way. Many times. Oh, I remember what it was. So you, I don't know. Do you remember what the form looked like with the little? So one of the ways it was. Let's say G.
XYZ. Right?
Which one? Mhm. And then like a why not? So that's the technical form. So, oh, I got to print it. I forgot to square it. Well, actually, it's not necessarily always square, but that's meters. This is the form that you would square in this case. So just try going by that idea. Right. See if you can get it. Yes.
So I'm working on 9. So it's saying to see exercise 4.
Oh, as endpoint of the diameter.
Yeah.
Okay, so
I'm assuming it's pointing towards this. It's pointing towards this. Set up a little bit. Because I was thinking like, so we have to relate it. So it'd be 1 plus 3, or like would be the square root.
distance.
Yeah.
So yeah, try using distance formula and see what you get.
Okay. Thanks.
Do you have a question or just Sarah?
This would be the negative x, right?
There's yes, there's a question of buzzing in a long time. We have
I would use it as
do dot product.
Oh, dot product?
Yeah, well,
Over here.
Yeah,
I supposed to even like.
I use dot
Yeah.
product
I just like that.
and
It was really bad.
well, you won't have to worry about dot product later, but we'll. My question is, I use dot product. Is a number, and the actually correct number is
and I mean, it's showing it.
I you know,
I don't even know like.
Oh, yeah, there's different ways of doing it. I think I vaguely remember that.
so that way I can get it right. But when we talk about I don't know why. I have a couple of different questions from the verdict from the close down.
Sure, I couldn't tell you exactly what I can tell you is that in different ways of doing things, you'll find that, especially with animations like that, you'll find that it's not those. I definitely have a long time when Pearson, I think the second year.
Yeah. So
Like when you try to do it a certain way, which is just as valid, but it would give you a slightly different answer. I remember that's it because it was their answer. It wasn't within their recommendation. Yeah. So it could, it could be just as possible. It's just a estimation error. I could.
I gotta go remind that. I haven't do it in a while.
Yeah.
Like points.
So,
You know
Want to be like right here.
Yeah.
Where do I put the point?
You imagine, and I hope you can understand. Because it really.
Like, I want to put the point up here, but then one would be down here. So I'm like, let's put the point here.
Try doing it.
I still can't do it.
You probably want all 4 axes.
I don't know, I could do this here one.
Oh, so don't worry. It took like, I used to have to make 2 graphs. One is kind of sketching it to get an idea of what this graph is. And the second one to actually make it. So don't have
Yeah, I'm like, what do I put?
yeah, so you got -6. Oh, you can go Yeah. Now just kind of look straight.
Oh, this is not like one to one, like.
No, it goes X, Y, Z.
Right, it's actually.
So it's like slightly above that.
I see.
Yeah, it's the power of imagination.
Yeah, I was imagining that coordinate one going down.
Yeah.
These are twos. I was imagining like right here.
Oh.
I think it's the same. It's like, no, it's like above and below. It's fine.
Yeah. I know the 3D graphics is gonna be tricky. We'll add a lot of that.
What is the?
Yes. I try to explain it.
Yeah.
Probably
overthinking that.
Oh. Yeah, you're just finding the coordinates. Yeah. You don't really know the box.
Yeah.
You can't do that. I mean, I'm not.
Yeah, but it's really all up to you. It's kind of about this class.
Yeah.
Wait, just find the coordinates of the 8 corners of the ball. Oh my god, I was overthinking this.
When they roll in.
Right. So I can understand the ball.
Oh, yeah, the bathroom pass.
Worry about it. It took me so long just to understand what the first question was asking.
Yeah, I got that.
I thought it was asking for the equation. Then we went to this and I was like, wait, what?
Yeah.
That confused me. Yeah, I was like, that's not, I didn't see this find equation. I read that. I read that it's five. Which one?
I'm trying to find out the 6. It says find the other 6 coordinates.
Finding the equations of the equations of the sphere. That's why when I went to the, I was like, I believe.
All right.
I didn't understand what it.
It doesn't have a perfect.
Yeah, I gotta wait. Okay, so you get the decimal like 17.
Actually, never mind. I did. That's a shape.
Okay, so
Irregular.
so if you find something, you could give it a. Oh, just let it.
Oh, that. Well, that's not technically a bomb. It's just very small rounded edges still.
Well, if you take it to infinity, it will become a box, right?
So right now, you know this.
Yeah, in tech, yeah, I guess technically it might come to that.
I mean, I guess I thought it was made. That's what I'm also having a hard time. How do I know which points I even have ready?
It's the same.
What?
You know
Well,
this.
I think it was-
And you know that.
I think it was senior.
Right? You don't have to know. What exactly you are.
Yes.
Right.
You know this one, then you know this one.
All right, so I did.
Always.
Gotta.
Diagonals.
Right.
Well, it's hard.
It's always
That's how boxes are. They're not active.
So you only need to.
The papers get rated.
This should be the distance
That's
between
what
that,
it's-
so you
you're
just
not-
divide it by 10. Yeah, that would give you.
You're not- Yeah, because you don't take into account
Thank you.
the box.
Okay, so
I
from.
think that's right. Yeah, because that's the diameter technically. Yeah, so you divide it by 2. and you get the radius. Yeah, okay, cool. Yes.
Yeah, so that's that. I just realized that boxes are actually boxes.
Okay. This point and this point, what they're only difference is actually.
Look at that square. He just did the same. He did the
You
same
can change it.
function. as a sphere, but if you zoom in, boxes are curved. Really, this is a box. You think that's a box? Or is it
You
actually
just have to kind of to make those. I'm not.
Copy this, guys. I'll read your. And which one is different? No, nor is different.
Yes.
And you just,
Smurf, do you have any questions?
right, because now it's on the same plane as that. Now it's on the same.
Yeah, there you find those. What's the?
And so you're wondering how to do that?
So it's like, is it,
That one.
it's not X by B,
You can write it after the first.
the order of the coordinates.
Yes.
Y,
Yeah, you got to create that
Y,
Y.
X, usually X is X, Y.
Yeah.
One, no, this
I
one.
already.
One back to six.
Oh, the
So it's, you just add your. X.
So we
Oh,
yeah,
so
like
it's
this one where I. Yeah, it's 1, 1.
Yeah. I don't like.
It's really staring at it, and I'm like, I don't know way around.
Yeah.
I got those
Four,
things.
One
of these. It's also going to be six. But this is like perfect.
Now it's,
Just add
two.
Which one's it?
C is by one.
X.
Yeah. But I'm.
Yeah, Mr. Jones, you got a question that I can't seem to answer.
Okay,
Number 9 on the exercise. You have the
Okay.
book.
yeah, I do. 1 second.
Okay.
All right, number 9. Let's see, what do we got?
Yeah.
Find the center and the radius of the sphere. Let's see. 1, -2, and 4. And 3, 4, -12 are endpoints of the -12. Okay, those are the endpoints. So one way we could do this, we've got 2 points here, right? We could find the distance between the 2 points because we know the center, if we're passing through the diameter, is the midpoint of the diameter. Which would mean half the distance. When you're doing midpoint rule, it's add up the 2 numbers, divide by 2. So the x components are 1 + 3 / 2. 4 / 2 is 2. The y component is -2 + 4 / 2, which is 2 / 2, which is 1. And z, the midpoint, is 4 + -12 / 2. What is that? -8 / 2, so -4. Our center is going to be 2, 1, and -4. And they want the radius. Here, the radius, I would just do the distance formula with either one of these. If you do the distance formula with these two, you have to divide by 2. If you do the distance formula with this point and one of them, you don't have to divide by 2. But since, just to make sure I'm using stuff that I know is accurate in case I fuck that up, if I fuck that up, using this to calculate the radius is bad. So I'm going to go back and I'm going to do it with the upper ones. X2 minus x1 squared. So I could do 3 minus 1 squared plus, I'll do, this is the x2 minus x1. We'll do y2 minus y1 and z2 minus z1. I made this point number 2. So I will make this point number 1. 4 minus -2. And I've got -12 minus 4. So my distance is 3 minus 1 squared, 2 squared is 4. 4 minus -2 is 6. 6 squared is 36. And -12 minus 4 is -16. -16 squared is 256, I believe. So I got, this is 40. I got D equals square root of 296. That might be a number, but I don't know what it is offhand. It sounds familiar. Let's see, 16 was 250. So if it's anything, it's 7. Now 17 would end with a 9. Let's see, square root of 296 is approximately 17.2 units, whatever the units said. So the radius would be half that. Approximately 8.6 units. I bet y'all forgot the midpoint rule, didn't you?
Yeah, I forgot midpoint roll. It's the, if I'm correct, it's the second one minus the first one divided by 2.
No, midpoint is add them both.
Oh, it's add them. Oh yeah, because you're finding, yeah, that's right. So you find, you add the, so you have an x value and an x value, you add those together from different points, and then you divide both that, them add together by 2. And that will give you the midpoint. And then you
It's
do that
how it
for
works.
all 3.
Yeah. It's how it works in 2D. This is what you've learned in 2 dimensions. Scaling it up to 3 just means adding in the Z component.
Yeah.
It's pretty handy that it just scales up.
Yeah. Is there any questions?
Yes.
Yes.
So I'm using different points. So I'm using -4 and -4. So over here, is that gonna be -12 class or? Because the point is -4, -5. This one minus this one becomes 5, right?
Well, you're not tracking it for midpoint roll.
No, not midpoint. It's
So just drawing.
Oh, distance. Yeah, so
Like sitting here, like,
subtract the negative, yeah. Oh, distance formula.
Right.
Was what was the
Point, I'm using the first one, so.
And I'm probably gonna see how I have this
Minus
block
wall,
like.
it should be, so this becomes class 4, right? Minus 12 from.
How are those? This would be. Like right after this, you have class. You get
This,
Fridays, I'm gonna try to do different than try to accommodate. So I know you guys don't work Monday.
Oh, I got some. I'm so confused because I thought you were still using this.
Yeah, so Friday we can start working on. So it's on Monday.
Yeah. Just making sure that, you always make sure that you have your points in the right spots. Yeah, you're good.
Monday.
That doesn't look good. Oh, you got it. Oh, that's what, yeah, because this is the, oh, I see what you're saying. So that is the diameter. So when you have the radius, what you use for the distance formula is between these 2 points. And what you get for the distance formula is between these 2 points. So if you do multiply that by 2, you will actually.
How do I do this? How do I fit this on?
You have right
Yeah. So I'm trying to write all the points.
So it's not.
Wait, the right corners only? Oh, no.
So
the eight
that's-
corners. The eight corners.
The safer way is you can endpoint and get the answer.
How does it all the right corners?
That was my
Yeah.
last result, right?
Yeah,
Picture
that is
that.
probably I remember some of my high school physics teachers before I would say, if you only use, try your best to only use the values that you are given to you rather than one that you think of it, because you'll create more potential.
Oh, right.
Of course, that doesn't usually always work out. It's like professional probably
I
ask.
don't have the, I think it was the measurement. We're taking a draw.
Oh, sorry. Yeah, I have my online.
Thanks, bro.
My SI, it should be on campus, but on Mondays and Fridays, 12 to 2, and on as well as Fridays, 8:30 to 9:30.
More excited about
So
trying to draw this box, right?
Did you do that one?
I'm just like trying to get this looks funny. I think I found a problem with how to do it. No, I'm just trying to like draw stuff. Like, I don't know, hard time. You know, figure it out.
No, you'll either have to live with it or just get better.
Yeah.
It's just
I
that.
think I'm gonna have to spend like a weekend just drawing shapes.
Hey, that's what we're doing.
It does say this. describe it.
I have office hours from 1 to 2.
Last one.
If you guys want to go to office hours,
There's four.
If you think you're sure, if you know.
Oh, she's right, 9.
Yeah.
Spent the last 20 minutes
But
drawing
you
a box.
might. Yeah, you might. actually have to do a
I finally finished the first problem.
Hey, let's go. I just spent the last 20 minutes trying to draw a box.
No, but I don't know. I had to go through the process on how to do it like quickly because I kept looking back to the problem because I didn't have the lines on it. I know. Well, that's something. Yeah, that's not that's not what. Well, yeah, you don't have to draw a box, but I did that there. Yeah. I get you.
Do you have any other announcements?
that's it. I will make sure you watch 11.7 tonight. 11.2 is not the next section. 11.7 is. We're gonna get the
Yeah.
hard 3D graphing shit out of the way so that we're not dealing with the graphing.
So that playlist you provided, that is correct.
Yes,
So 11.7 is the next one, not 11.2. All right.
Hey, thanks, Brandon, for your help.
yeah, we're
Sure.
getting rid of it. We're getting that graphing shit out of the way.
Yeah. All right.
Thanks, Professor Happy. Have a nice day.
See you guys tomorrow.
Sure. I'm gonna have to wrap up quickly too. I have a lab in 10 minutes. In 10 minutes here.
I'll talk to you later.
Yeah.